Okay, this is 1.3, separable equations. And guys, this is, you already did this in Calculus 1, so we're going to do a couple of exercises. Rather, I would like to focus on some physical applications like radioactive decay and population growth, which you know from pre-calculus, that exponential function you guys were asked to memorize. Here we're going to learn where it's coming from. Actually, you did it in Calc 2, I guess, also. Newton's law of cooling, that's another cool method, pun intended there. What else? Chemical mixtures, so that's very important, so you'll see. Okay, how do we describe a separable equation there? Okay, so general first order differential equation of the form dy dx equals to some function of x and y. It's separable if this function f of x, y can be written as the product of a function of x and y independently, right? Or a quotient. I mean, technically a quotient is a product, so of a number and the reciprocal of a quantity. So this is still a product anyway. Like, for instance, what is that? These two equations, dy dx equals to sine cubed of x plus cos squared of y. By the way, there's missing parentheses here. So the cos operator is only for the y, not to the exponential function. Is that a separable equation? Let's find out. Okay, so actually let's talk about the exponential factor there. So this is equal to, okay, sine cubed x cos squared y. How about e to the 3x squared plus 4y cubed is the same as saying e to the 3x squared times e to the 4y cubed. Okay? So does that look like a product between two functions, one function of x and one function of y? Okay, let's see. So how about we group? This is sine cubed x e to the 3x squared cos squared y e to the 4y cubed. How about this is some function of x times some function of y? So that's a separable equation, right? We can separate the variables and then integrate both sides, provided, of course, the functions are integrable, right? That's one. How about the next example? dy dx equals to y squared plus arctangent of x. Is that a separable equation? In other words, can you write the right-hand side of the differential equation as a product of a function of x and a function of y? I don't think we can in this case, right? Because this is an addition. This is some function of y plus a function of x, not a product. So, not separable. So we would need another method to solve that kind of equation. Well, that's actually non-linear first order. We may need maybe a substitution, maybe it's a Bernoulli's, maybe it's a Riccati, I don't know. Well, we will need to figure it out. That's not the point anyway. All right, we want to focus on separable equations. So I think we may have time to do one exercise. So when it comes to solving differential equation, we just don't want to know what the solution is, but also the validity of the solution. In other words, all we need to look at is the domain of the actual solution to find the intervals where for the validity of the solution of the equation. Okay, so let's have a look at one example. So number one, dy dx equals x squared over y squared. Does that look like a product between a function of x and a function of y, or a quotient? Yeah. It is. So that means we can separate the variables. And in this case, we could simply go about cross multiplication. That's going to do it. Okay? That's going to do it. So that's y squared dy equals x squared dx. Now that we separated the variables, we are ready to do or to undo what has done. That is, it's been differentiated. We undo the differentiation by integrating both sides. All right, make this look like an x. So that's y cubed over 3 equals to x cubed over 3 plus c. Again, guys, like I discussed in at the beginning of the lecture, we don't write the c on both sides. I mean, you can. I already went through that. You can combine then combine the two c's together, and by absorption just come up with only one. So for convenience, we only write it on the right-hand side of the equation. Okay, so we are somehow done with the solution, but I mean, oftentimes you want to get the solution in explicit form. That is it possible to solve for y in this case? I believe it is. It is possible to solve for y. Well, so let me multiply both sides of the equation, by 3 in this case. So that's going to cancel, that'll cancel the 3's in the denominator. That's y cubed equals to x cubed plus 3c. Okay, guys, when it comes to multiplying both sides of the equation, when it comes to multiplying by that number, by that constant of integration, by absorption, 3 times a number that we don't know what it is, it's just another number because, again, we don't know what it is, right? So, by absorption, we're going to do a lot of this, okay? That's y cubed equals to x squared, cubed, plus just another c. Or if you prefer, some other textbooks or YouTube channels or whatever call it a k and then a c and they just use another letter, or a c1, a c2, and in the end they just call it a c. Doesn't matter, okay? And well, in this case, we can solve for y by taking the cube root on both sides. And this is our explicit solution. And this guy right here is the implicit solution. All right?